whichever I mentioned. So let me see the question. Okay, so so this is first picture you see on Brightspace. From here, you do all 1, 2, and 3.
Okay.
And then there's a second picture below this one from our book. Do question 2, A to F, question 3A, 4, A to F, 5. I think I changed BD to only 1, 5D or something. So those from
Yeah,
the
you
second.
changed it to 5D.
Mm-hmm. So I think total 10 questions or something like that. Not 10, sorry. 2 and 4, they're just conversion from matrix to system of equations to matrix, or matrix to system of equations, something like that. So the actual math is actually question 5 and this 1, 2, 3.
Okay. I got it now. Thank you.
No problem. And also remember, guys, do them on your paper and then take pictures or scan them, do whatever you want to do, and then combine everything into one single PDF file. So you cannot have multiple PDF files. You can upload only one PDF file. And if you don't upload PDF file, that will not allow you to, the Brightspace will not allow you to upload anything besides PDF. So you have to have a PDF file, and you have only one submission. So you need to convert everything into one. You need to join all the files into one PDF file. Okay. Any question before we start? No. Okay, so in our last class, we started talking about properties of matrices, and we said two matrices have the same size if and only if they have the same dimension. Means number of rows and number of columns in all the matrices have to be same. And then two matrices are equal if they're identical, like they have exact elements in each of the matrices. And then the third property is two matrices of the same size. We can add them as long as they have the same size. The elements may be different, but if they have same size, the dimension, then we can add them, subtract them. So we are going to do some examples. Like here, we have matrix A. Let me write down its dimension. Matrix A, 1 by 1.3. Oh, yes, this is 1.3. We are still doing 1.3. Okay, so matrix A has dimension. We have 2 rows, so 2, and we have 3 columns, so it's 3. So the dimension of A is 2 by 3. That's therefore the dimension for B also 2 by 3. We have 2 rows and 3 columns. Since we have same dimension, that means yes, we can add them, subtract them. So A says find the sum of the two matrices. So C is A plus B. A is 1, 4, 2, 5, 3, 6, column wise. And you're adding the B matrix, which is 7, 10, 8, 11, 9, 12, column wise. So when we add each element on their position. So our first position here is 1, 1. So we add the two 1, 1 position. We get 7 plus 1, 8. Our next position here is 2 on the second column, first row. Here we have 8 in the second column first row. So we are going to add 2 plus 8, we get 10. Then on the same row, we have in the third position, first row, third column is 3, and first row, third column is 9. So we're going to add them. We get 9 plus 3, 12. We are going to do the same thing on the second row. Second row, first column is 4 and 10. So we're going to add them. We get 4 plus 10, 14. Then in the second position of the second column is 5 and 11. So we are going to add them. We get 5 plus 11, 16. Lastly, in the last position, in the second row is 6 and 12. So you're going to add 6 and 12. You get 18. And then you put your square bracket. Every matrix, we use square bracket to represent, but sometimes people also use a big parenthesis instead of square bracket. But square bracket is normal, and parenthesis is not too normal. And this is our answer for A. Any question? That was easy, right? Not too hard. Now, who would like to try B? You're subtracting A from B. So letter B. Christelle, go ahead.
So I think that all elements in this matrix would be 6, but to do them all, you would first start with the position 1, 1. So it'd be 7 minus 1, which is 6.
7 minus 1, 6.
And then we go to 1, 2. It would be uh, 8 minus 2, which is 6. And then it just continue on being 6 for all position elements.
All of them. And you get 6, 6, 6. Good job. This is correct. So any question? That was easy. Now the next one. The next one says, if Z is a zero matrix, consists of all entries 0, then add that zero matrix with any other matrix will give you the same matrix back. For example, let's suppose our A is 1, 2, 3, 4 row-wise, and our Z is 0, 0, 0, 0 row-wise. Now, if you add 1 plus 0, you get 1. 2 plus 0 is 2. 3 plus 0 is 3. 4 plus 0 is 4. So you get the same original A matrix back. So in other words, adding a zero matrix or subtracting a zero matrix with any matrix doesn't change anything. The next property says to multiply a matrix by a scalar, any non-zero number, multiply each entry by that number in the matrix. For example, if we have A is 168 row-wise, 2, negative 14, 12 row-wise, negative 4, negative 10, negative 14 row-wise, and you want to find what is negative half of A, it means you're going to multiply every entry here by negative 1/2. So 1/2 of 1, negative 1/2 of 1, negative 1/2 of 6, negative 1/2 of 8. You're going to do that to every element. So negative 1/2 of A is 1/2 of negative 1/2 of 1, which is negative half. Then negative half of 6 is negative 3. Negative half of 8 is 4. Let me erase this so that you can see clearly. Then the second row is 2, negative 14, 12. So 2 times negative 1/2 is negative 1. Negative 14 times negative half is positive 7. And negative half of 12 is negative 6. Negative 4, negative half is positive 2. Negative half of negative 10 is 5. And negative half of negative 14 is 7. In other words, you're multiplying each entry, each element in a matrix by negative half, and you get the result. So we are allowed to multiply any matrix by a non-zero scalar. Now, using these properties, there are a few questions. So here I have 3 of them. We don't have time for 3. I'm just going to do 1. Here they're asking to verify that in each equation, the left side is equals to the right side. So in B, we have 5a. This is same as 3a plus 2a. In C, it says 6a is 3 times 2a. So any preference do you guys have between among A, B, and C? Which one you want me to verify that for you? A?
Can we do
Okay.
A?
Sure. Would you like to try it? You're going to start one by one. So first you're going to do left side. So left side says add a plus b and multiply by 3. So 3 times a plus b. 3 times what? Who would like to be my volunteer?
I can volunteer.
Okay, Rahman, go ahead.
It will be -6.
Minus 6. So you're
10.
adding 1 minus 7.
Yeah. 10.
2 plus 8 is 10.
And -6 again.
3 minus 9 is negative 6.
Yeah. And then 14.
14.
16.
16.
And lastly 18.
18. Good job. Now you're multiplying each element by 3. Oh man, these will be big numbers.
So is it like only the top or each of all of them?
Element. You're going to multiply these 3 by all of them, one by one. So 3 times negative 6.
It's -18.
18.
Then
3
30.
times 10, 30.
Then
3
again
times negative
18.
6, negative 18.
Then 42. Yeah.
52, I think. No, 42. 42.
No, 42. Yeah.
Uh-huh.
And then
42.
48.
48.
And then this one is 54.
54. Perfect. So this is the left side. Now you're going to do the right side. So this is left hand side. Now we are going to see if right hand side gives us the same thing or not. So right hand side says add 3a with 3b. So who would like to try 3a? Volunteer for 3a. All right, Professor, just to make sure, like the order of operators doesn't matter for the skeleton and order of operation does matter. Just like pandas, you have parentheses, exponent, multiplication, division, addition, subtraction. So you have to follow that order. So left hand side says 3 times a plus b. You have to do the a plus b first and then the multiplication. So if you do the multiplication, you get 3a plus 3b. So we are going to verify that if you distribute, you're going to get the same result as if you add first and then distribute. So Rayat, would you like to try 3a? What is 3a, or what's the matrix for 3a?
Wait, can you hear me?
Yes.
Okay, so for 3A, the matrix would be, for the first row, it would be 3, 6, 9.
3, 6, 9.
And then for the second row, it would be 12, 15, 18.
Perfect. How about 3b?
For 3B,
Mm-hmm.
it would be, for the first row, you would have negative 21,
Mm-hmm.
and then you'd have 24, and then you'd have negative 27,
Mm-hmm.
and then for the second row, you'd have 30, and then 33, and then 36.
Perfect.
Great.
Would you like to also add?
No.
No? Okay, who'd like to add? Yep, Valerie. Valerie, would you like to try 3a plus 3b?
I can do it.
Okay, Soraya, go ahead.
For 3a plus 3b, I got negative 18,
Negative 18,
30,
30,
negative 18 again,
negative 18,
then 42,
42,
48,
48,
and 54.
54. Now, if you look at the left-hand side, our first column is negative 18. So the first row is negative 18, 30, negative 18. We have the exact same thing on the right-hand side. Then the second row is 42, 48, 54. We have the exact same thing on the right-hand side. So what does that mean? It means if we have 3 times a plus b, either you can do the addition first and then multiplication, or you can distribute first and then you can add. So you have 3 choices. Distribution could be first and then addition, or add first and then distribute. So it's called distribution property. When you have matrix addition and scalar multiplication, you can you can distribute the scalar to your matrices. And the other two are same. First, you are going to do left-hand side and then do right-hand side and check whether they're same or not. Okay, Ahmed, I understand. Okay, so I think you're going to do one of these questions in the homework. So that's all you have to do, okay? Take the left-hand side, follow whatever is given, and then look at the right-hand side, follow whatever is given, and then compare left-hand side with the right-hand side of the equal sign. Now comes the most important part, matrix multiplication. This is one of the most important parts in matrix algebra. So where we need matrix multiplication. In real life, we actually use matrix a lot without even realizing that we are using it. So we don't use it manually by hand, but we input that into the computer and computer does everything for us. So some example where we do use matrix multiplication is, for example, if you have a business, in business application, it's important because inventory matrix is when you multiply cost per item and the result is the total cost matrix. So you have an inventory matrix and cost per item. When you multiply them, you get your total cost. for any type of business. So if you have a large business, then you input everything in the computer, and the computer does the multiplication and gives you the result. Another example is if you have a bunch of items to buy and they have different price for each, you can use matrix multiplication. Like system of equations, you can come up with system of equations, input that as a matrix in the computer, and computer will do everything for you. And there are many other applications. So how we do multiplication? So when we added or subtracted matrix, we said there is one condition. They have to have the same size. Now for multiplication, it's not true. You may not have the same size, but you still can multiply. However, multiplication has another requirement. The requirement is that the number of columns in the left matrix must be same as number of rows in the right matrix. For example, if you look at A matrix here, which is 1, 2, 3, 4, 5, 6 row wise, we have 2 rows and 3 columns, so its size is 2 by 3. Now for B matrix, we have 1, 2, 3 rows and 2 columns, so its size is 3 by 2. You can only multiply matrices if this number is same as this number. So number of columns on the left matrix has to be same as number of rows on the right matrix. So column row, CR. If CR is the same number, then you can multiply. And when you multiply, the resulting matrix will have number of rows here and number of columns there. So condition is CR, and the result will have the size row and column. So condition can start with C. So you need to check C first. Number of column on the left matrix have to be same as number of row on the right matrix. So condition is CR, then the result will be RC. For example here, since this number of column is same as number of row here, so can we find AB? Means can we multiply A times B? The answer is yes. We can multiply A by B because the number of column in A is same as number of rows in B. Now when you multiply, what will be the dimension of your resulting matrix? It will be number of rows on the A matrix by number of columns in the B matrix. So in this case, we have 2 row and 2 column. So it will be 2 by 2. Okay. So for addition subtraction, we are going to get the exact same size back. But for multiplication, we are not going to get the exact same size back. We may get it, but there's no guarantee. The size depends on RC, means number of row in the left matrix and number of column on the right matrix. Now volunteer for the next question. We have A, 1, 2, 3, row wise, 4, 5, 6, row wise, and our B matrix is negative 1, 6, 0, column wise. Rakmanjan, what's the dimension for A?
Oh, it's 2 by 3.
2 by 3. And dimension for B?
It's just one column. So
Yeah,
1
but
by
how
1.
many rows?
No rows. So just
Not no rows. You still have a row. Row 1, row 2, row 3.
Oh, 1 by 3.
You always have to write row first and then column.
3
So
3 by 1.
3 by 1. So 3 rows, but only 1 column. So can you multiply A times B?
Wait, can you explain why we wrote 3 by 1? What did you? I couldn't hear you.
So this is row 1. This is row 2. This is row 3. So we have 3 rows.
Oh, okay.
But
Yeah.
how many columns?
Yeah.
Only one. So it's 3 by 1. Dimension always has row by column. Row always comes first.
Yeah. Yeah.
So can we multiply AB?
No,
Why not?
because the rows are not the same.
Condition.
Yeah.
Condition is CR, means number of column on your left matrix have to be same as number of row on the right matrix. So this is our left matrix A, and this is our right matrix B. How many columns we have in A?
3.
3. How many rows we have in B?
3.
3. As long as these two numbers are same, we can multiply.
Okay.
So the answer is yes. Now when you multiply, you're going to get a new matrix. What's the size of the new matrix? So result. You have A matrix, B matrix. What would be the result of what would be the resulting size of your product matrix? Once you multiply A and B, not 3 by 3. 3 by 3 is the condition. And the result will be 2 by 1. So it's row by column. So row in A matrix by column in B matrix. So we have 2 rows in A matrix and 3 columns in B matrix. So result, it didn't say anything here. Come on, please don't do that. Oh man, I hate that. Let me save this. Wow. Not info, sorry. Save. Save. Yeah. Now it's freezing. Pause. Ah, can I write now? Okay, I can. What I was doing, dimension. So dimension or the size of AB is 2 by 1. And for answer why, it's because number of rows in A matrix is same as number of column in the B matrix. Well, I can write it, so I have to go from here and restart. Give me 1 second. Sorry, 1 second is not enough. Probably 1 minute. Give me 1 minute. Okay. In your homework, you're going to do few examples like this, where they'll ask you whether the matrix multiplication is possible or not. So all you have to look at CR, means number of columns in the left matrix and number of rows on the right matrix. So let me write this again. Size of AB is 2 by 1. Now let's do a few more examples, which you're going to see in the exam. Also, so this will be in the exam, also in the homework. So let me do the first one. we have 1 row, 2 row. So this is 2 by 3. And we have 1, 2, 3 rows. So this is 3 by 2. Now it says determine whether matrix multiplication is possible or not. And let me include one more thing. If possible, what's the size of the product matrix? Product matrix. So first identify the size of each matrix. Based on that, figure out whether matrix multiplication is possible or not. If it's possible, what's the size of the resulting product matrix? So here we see number of column here is same as number of row here. As long as these two numbers are same, matrix multiplication is possible. Yes. And since you can multiply them, the result, the product matrix will have the size the other two, which is 2 by 2. Okay, so that's what we're going to do in this question. Now volunteer for B. Who would like to try B? Crystal.
Okay, so if you look at the first matrix, it would be 3 by 2.
Mm-hmm.
And then if you look at the second one, it would be 1 by 3.
1 by 3.
And because, sorry.
Go ahead.
Oh,
Can you multiply?
No, you can't multiply it because the number of columns is not the same as the number of rows.
Mm-hmm. So these two, not same. Perfect. Volunteer for C. If no one volunteer, I will call you guys. Okay. Julian. Are you there, Julian? If you don't know, it's fine. I'm going to help you anyway. So are you there, Julian? Okay. Matthew. If you don't respond, guys, I'm going to mark you absent. Karma, go ahead.
Wait, for number C, right? Or letter C?
C.
So it would be, the A would be a 3 by 2.
3 by 2.
And then B would be a 3 by 3.
3 by 3. So can you multiply them?
No, because the 3 and the 2 do not match.
Perfect. Not same. Thank you, Karma. Rayad, go ahead, the next one.
Oh, Professor, I had a question, like just some
Go ahead.
clarifying. I was gonna ask, like, you're just basically looking at like if the values match up, right? But then, like if they have like different values and
Number of columns on the left have to match with number of rows on the right.
Oh, okay. I see.
So would you like to try with D?
Oh, okay, I could try it. So for matrix A for part D, it looks like it's
How many
it's
rows?
a 3 by 1.
3 by 1. Good.
And then for this the second matrix, it's a 1 by 4.
Perfect. 1 by 4. So can you multiply them?
No.
Remember, number of column and number of rows, they have to be same. Do you see the same number?
Yeah. So it'd be a 1 by 1. So you could multiply it.
we can multiply, then what would be the dimension or the size of the resulting matrix, the product matrix? Once you multiply them, what will be the size of the product?
Oh, 3 by 4.
Good. Perfect. Now I see so many people raise hand, but now I don't see anyone. Raise your hand, guys, again, whoever raised the hand. I have 4 more examples. So go ahead, the next volunteer. I just saw you guys raise hand a few minutes ago. Come on. Abdel, Ahmed. Ahmed, if you're talking, I can't hear you. Oh, you're writing. Okay. So first one is 3 by 2. Okay, and the second one is no, actually,
Isn't
no,
it 2 by 3?
2 by 3. Yeah, you have to write number of rows first. So number of rows is 2 by 3, and this one is also 2 by 3. So can you multiply them? We cannot, because this number and this number, they are not same. Not same. Yep, man. Man, right? I keep forgetting the pronunciation.
Hmm.
Uh,
Don't worry, it's okay.
so what did you tell me before? Remind me again, please. Man or
Man.
main? Man, right?
Yeah, I don't mind because like it's either in French or in English, so I'm good with both of them.
Okay, then. Thank you. Tell me the next one. F,
It's a 2 by 2 for the first
2 by
one
2.
and a 2 by 3 for the second one.
2 by 3. So can you multiply them?
Yeah, we can.
So what would be the dimension of the result? So these two numbers are same. That's how we can multiply.
Yeah.
So what would be the result?
Oh, 4?
No, the other two.
Oh, 2 by 3? Like,
2 by 3. So you look at one pair to determine if whether multiplication is possible or not. And then if it's possible, you use the
okay.
other two to get the dimension for the result.
Oh, okay.
Great. Now next volunteer for G. Jalori. And then Mohammed, the last one.
For G, it would be 3 times 2
3
and
by 2.
3 by 2 and 3 by 3.
3 by 3. So can we multiply these two?
No, because 2 and 3 are not the same.
Perfect. 2 and 3, not same. Good job. Mohammed, the last one.
So the first one is 3 by 3.
3 by 3.
Second one is 3 by 2.
3 by 2.
And yes, we can multiply because the column and row are the same, 3, 3. And the size is 3 by 2.
3 by 2. Perfect. Good job. So now you guys know when we can multiply and when we cannot. Now, if you can multiply, then how you are going to multiply? We are going to start with easy one first. Let's say we have a row vector and a column vector. So in this row vector, our size is only one row, but we have 1, 2, 3 columns. So it's 1 by 3. And in the column vector, we have 1 row, 2 row, 3 row. So it's 3 by, and you have only one column, 1. So when you multiply a row with a column, we are allowed to multiply as long as number of row and number of column are same. And then our results, the product, will have the size 1 by 1. It means it will be a constant, a number, just a number. 1 by 1 matrix means it's a scalar. Now the result will be a number. Okay, so I'm not going to multiply. I'm just going to tell you that if you multiply a row and a column, you're always going to get a number, just one number. Now let's see, you're multiplying 2 by 2 matrix, two of them. So let's say we have A and B. So we have 1 position, 1 2 position, 1 2 1 position, and 2 2 position. Same thing. So let's say this is A. And let's say in B we have B 1 1 position, B 1 2 position, B 2 1 position, and B 2 2 position. So since both of them are 2 by 2, we can multiply and the result will be 2 by 2. Now when you multiply, what we do is we take one entire row and we multiply one entire column. And when we multiply individually each element in the proper position and we add them. For example, we have on the left page, our row is 1 3 5 and our column is 2 4 6. So when you multiply, we are going to take position 1 1 and position 1 1 here. We are going to multiply them. So 1 times 2. And then we are going to add the product of the next positions. So next position is 3 here and 4 here. We are going to multiply them 3 times 4. And then we are going to add the product of the next position. Our next position is 5 here and 6 here. So we are going to multiply 5 and 6. And then we are going to do the multiplication and addition. So we get 2 plus 12 plus 30. We get 44. So when you multiply one row with one column, you get only one single number, and that single number will be in 1 1 position because you took row 1 and column 1. So its position is 1 1. We are going to do the same thing in the next position. We take the first row and second column. So remember, row number 1, column number 2. So result will be in the position row number 1, column number 2. You're going to do the exact same thing what you did for 1 1 position. You take each element, so this element times this element plus the next position times the next position. The result will be in 1 2 position. And you're going to keep doing that until you cover every single column in your right matrix. Once you're done with all the columns on the right matrix by multiplying by the first row, then you're going to go to the second row. So second row is this, and you're going to start the same process again. Take the second row, multiply the first column. So when you do that, you take each position, multiply them, and then add the product of the next position. And the result will be in 2 1 position because you took row number 2 in the left matrix and column number 1 in the right matrix. So result has to be in 2 1 position in the product matrix. And we are going to do the same thing again in the second column, third column, fourth column, fifth column, until you are done with every single column. and then you go to the next row. So take one row from the left matrix and multiply all the column in the right matrix. Let's do one example. We have a 2 by 2 matrix, 7, -8 row-wise, and -3, 9 row-wise. Our B matrix has 8, 8 row-wise, and 3, -4 row-wise. So position, we have 2 by 2, 2 by 2. That means we can multiply, and our result will be 2 by 2. 2 by 2. This one. So this is result, and this is condition. Result, R-E-S-E-L-T, result. So let's do the multiplication. We take, let me change my color to yellow. We take the first row in the left matrix. So we are multiplying A on the left, B on the right. So you have to take the first row in the A matrix. So AB. We have 7 times. We take second column, first column in the second matrix. So one row, one column. And now multiply them. So 7 times 8, position 7 and position 8 here, plus we have -8. Come on. I hate that when that happens. Let me restart Word again. Ah. Oh, so let me start from the beginning again. So we are going to multiply A by B. The dimension for matrix A is 2 by 2. Dimension for matrix B is 2 by 2. The condition to multiply is number of rows on the left matrix have to be same as the number of rows on the right matrix. So for condition, we look at inner size. And whatever we left with on the outer shell, that is the result, the dimension of the resulting matrix. So our condition is fulfilled. We have 2 by 2. Sorry, we have 2 rows on the left matrix and 2 columns on the right matrix. So since we can multiply, the result will be 2 by 2 matrix. So we are going to get, why do we have this? We are going to take first row in the A matrix and first column in the B matrix. And then we're going to multiply the row and column. When you multiply row and column, we are going to take 1, 1 position in both matrix. So in 1, 1 position, we have 7 in A, 8 in B. So you multiply 7 times 8. Then we are going to add the next position. Next position in 1, 2 is -8 and +3. So you're going to multiply -8 by +3. That will be our constant in a 1, 1 position. Then we are going to do the same thing on the second column. Take your first row in A, but this time multiply the second column in B. And do the same math again. 7 times 8 plus -8 times -4. So first row in our resulting matrix is completed. So let me erase this. And we are going to go, let me also erase this so that you can see clearly. We are going to go to the second row in the left matrix. So second row in the left matrix is -3, 9. We are going to take -3, 9, and we're going to multiply first the first column, and then we're going to multiply the second column next. So the position is -3 here and 8 here. So we're going to multiply -3 times 8, and then we're going to add the next position. The next position is 9 and 3. So we do 9 times 3. We are done with 2, 1 position. Then we are going to go to the next column. We are going to have the same row, but use the next column. So we get here and there. We have -3 in the left and 8 on the right. So -3 times 8. Then we have 9 on the left and -4 on the right. So we are going to add 9 times -4. Oh man, what's wrong with this today? Right. Ah. Sorry about this, guys. Something is wrong with my laptop today, I think. Or with my pen. One of them. Come on. I'm actually using a Lenovo pen on HP laptop. That could be a problem. Annoying. Okay, so -3 times 8 plus 9 times -4. And now we are done with all the columns and all the rows. So all you have to do is simplify the math. 7 times 8 is... I'm actually too lazy, guys. Can you guys give me the answer for all 4 elements in our 2 by 2 matrix? 7 times 8 is 56, and we're subtracting 8 times 3, 24. Then we have -3 times 8 is -24.
We're gonna
And
have
we are
like
adding
32 for the first one.
32. Then we have column wise -24 plus 27. This is easy. This is 3.
I know the other one is 88. The second
88.
column. Yeah.
Okay,
Like the
so
first
from
row.
here, 88. And from here, we have -24 minus 36. So we're going to get -60.
The first one
Right?
is like 91.
91.
Yeah.
We have -24
Below. Yep.
and -36.
Oh, let me verify that again.
So 6 plus 4 is 10, and we have 3, 2, 4. So 3, 2, 5, and 1, 6. I think it's -60.
Oh yeah, it was 3. Yeah.
So this is a 2 by 2 matrix. This is our result, 2 by 2 matrix. We knew our result will be 2 by 2 matrix, and see, we got the 2 by 2 matrix. Yeah, I explained too much. Now your turn. Multiply these two. And let me know when you are ready. Who would like to volunteer to do this with me? So remember, first step is always figuring out your size. You look at the size. If the condition is fulfilled, then you determine the size for the result. So multiply 3 4 row-wise, 3 -4 row-wise with column matrix 2 -2. Is anybody ready? Who is ready? There should be easy one. Volunteer. Crystal, go ahead.
I'm not sure if I did this properly, but
No problem. I'm here to help you.
okay, so I started with the first row, and
But
actually, wait,
first tell
sorry.
me the size.
Yeah, the size is 2 by 1.
No, what's the size of the left matrix?
Oh, 2 by 2, and
2
then
by
this
2,
right matrix is 2 by 1.
2 by 1. So can you multiply?
Yes, we can multiply because 2 and 2 are the same.
Then what would be the size for the result for that?
The size will be 2 by 1.
2 by 1. It means you're
Yeah,
going to get 2 rows, but only 1 column.
yeah.
So go ahead, tell me the result. What did you do?
So first we look at the first row, and then we are going to multiply the first row by, yeah, by the matrix. So we start with 3 by 2,
3
and
times
then,
2.
yeah, 3 times 2, and then we add 4 times -2.
Perfect.
And then we look at the second row,
Mm-hmm.
and we're going to multiply it by the other matrix.
Mm-hmm.
And we would get 3 by 2, 3 times 2
Mm-hmm.
plus -4 times -2. And,
Perfect.
and I think that should go to be -2 and then 14.
So let's see. We have 6 minus 8, and then 6 plus 8. So -2 and 14. Yep, perfect. And the size is 2 by 1. So you got it. Who is lost? If you're lost here and you don't fix it, you'll be in trouble. Because in this course, the rest of the course is matrix multiplication. You're going to do a lot of matrix multiplication. So who is lost? Anybody? Now, who would like to be volunteer for the next one? It will be a big one. So if you guys want, you can do part by part. Like maybe one of you do some part, another of you do one more row, and then that person can do third row. If no one's volunteering, then I'm going to call you out. So volunteer for first row. So we always start with the size. It says multiply AB. So we need to see what's the size for A and B. A is 3 by 3 and B is also 3 by 3. Since 3 and 3 are the same number, so yes, we can multiply. And once you multiply, our result will be also 3 by 3. So result is 3 by 3 because our condition is fulfilled by having 3 by 3. So AB. Let's see. Christian, help me with multiplying first row and all these columns. So you start with first row and first column. Christian. Shahera,
Yeah.
you can do the next one. Go ahead, Christian.
So for the first row, it would be 3 times 1, so 3. And it would be 1 times -3, so -3. And then it would be 4 times 2, so 8.
4 times 2, 8.
Yeah.
Okay. So our result is plus 3 minus, you cancel out. We have 8 here.
Yeah.
Actually, I should do it on the right page because I don't have enough space. Insert one page. So we have 3 by 1 plus 1 by -3 plus 4 times 2. And our result is 8. Okay, then you're going to do the second column.
Yeah. It would be 3 times 0, so 0. 1 times 1, so 1. And it would be 4 times -4, so -16.
So we have -16 plus 1, -15.
Yeah.
And then the third column.
Yeah, it would be 3 times 2, so 6. 1 times 1, so 1. And then 4 times 1, so 4.
So how much is the total?
It would be 6 plus 1 plus 4, which is 11.
11. Perfect. Good job. I forgot who raised hand before.
It was me.
Okay, Soraya, go ahead. Do the same thing for second row. So
Yeah,
let
I finished
me
the whole thing.
whole thing. Okay, so second row, and then maybe someone else can do the third row.
1 times 1
1
plus
times 1,
0 times -3
0 times -3,
plus 1 times 2.
1 times 2. So
And
how much we get?
I got 3.
3.
And
So
then
now we're going to do the second column.
yeah, 1 times 0 plus 0 times 1 plus 1 times -4. And then I got -4 for that.
-4. Perfect.
And then the third column, I mean, yeah,
Third column.
I got 1 times 2
1 times 2.
plus 0 times 1 plus 1 times 1, and I got
1
3.
times 1. We get 3. Perfect. Now the last column, the last row. Volunteer for last row. Let me pick this color. Who would like to be my volunteer for the last one? We have only 3 more minutes. Volunteer, volunteer. Okay, let me pick. Omar D.
Yes. So, there will be 4 times 2.
4 times. You're going to do the first column.
Oh, first column. 4 times 1.
4 times 1.
4 times -3.
2 times.
2 times
So you go
-3.
element wise. 4 times the first one, 2 times the second one, and the third one times the third one.
Okay.
So you
2
did 4
times
times 1, 2 times -3, and what will be the last one?
2 times -2.
2 times 2.
That's a 2.
Yeah, let me.
Okay.
Sorry. 2 times 2. So how much is the total?
4 plus -6 plus 4. So 2.
I think 2, right? 4 plus 4 is 8. 8 minus 6 is 2. If I'm not wrong. Okay, then go ahead with the next column. So let me change all of this. So you take the same third row, but this time you go to the second column. You do element wise.
So that would be 4 times 0.
4 times 0.
And 2 times 1.
2 times 1.
And 2 times -4.
2 times -4. So what do you get?
-16.
-6, I think. 4 times 0 is 0. So we had 2 minus 8, -6. And then the last one. So you go to the third column and do the same thing.
So 4 times 3.
4 times 2.
2 times 1.
2 times 1.
And 2 times 1.
2 times 1. So 4, 2, 2, 1, and 2, 1. How much is the total?
Would that be 12?
12. Perfect. Now, A, B, I'm just going to write all these numbers down nicely. We have 8, -15, 11, 3, -4, 3, and then we have 2, -6, 12. A lot. So we multiplied AB and we got these results. Any question? Okay, Rakunjan, no problem. So, any question from anyone? No? So, that's how we do multiplication. So, in your homework for next week, you're going to do this multiplication, and these also will be in your exam. So, in our next class, we are going to do more examples about the multiplication, and then we're going to do transpose, and then a few properties, and then matrix equation, and then you'll be done. So next Monday, we'll be done with 1.3, and you're going to have your homework. So these will be the question for homework 1.3, 10 of them. It's not due next week, but if you want, you can start doing them. Okay? Thank you too, guys. Thank you so much for being here. And thank you so much for your participation. Have a good day. Have a good weekend. Be safe. Don't get sick.